Okay, this drawing is going to show how to draw, to a scale of 1:10, a stud partition, which is part of first fixing in carpentry and joinery. So, a starting point for this particular drawing is going to be from the bottom of the sheet. Okay, from the bottom of the sheet, you're going to come up 25 millimeters from the bottom of the sheet to the top of a concrete floor. What's going to be a concrete floor here. Okay, and you're going to move in on that same line there. Move in from the left hand side 40 millimeters to the outside of the outer leaf cavity wall. Okay, the outer leaf of the cavity wall, the outside of it. So in 40 millimeters from the left hand side. Now at scale 1:10, so basically you've got 100 millimeters, 50 millimeters and 100 millimeters for the cavity wall construction here. So scale 1:10, that's going to be 10 millimeters, 5 millimeters and 10 millimeters. Now the concrete pad, I just gave it a depth of 100 millimeter depth here for the concrete pad. You've got a line of your DPM going underneath the concrete pad and going up at the side of the concrete pad against the inner leaf here, and then at the level of the concrete pad here you've got it connected in with your DPC here on the cavity. Now that's the position for the actual I suppose the drawing. Scale drawing 1:10, as I said, so all the different components will be divided by 10. Now the height, obviously, from the top of the concrete wall to the bottom of the ceiling is 8 foot. So just give it 2.4 meters, which is 240 millimeters. 240 millimeters, if you want to make it 244, that's fine. But 240 at least to the bottom of the ceiling here. Okay, so from the top of the concrete floor to the underneath of the ceiling here, okay, it is 240 millimeters. Okay, 244 if you want to be precise, by way of 8 foot exactly. So the stud partition, if you give a break of 3 millimeters from the inner leaf here, the inside of the inner leaf, to the beginning of the stud partition. So basically each stud is going to be it's 95 by 45, so it's 95 on the depth and 45 in the thickness. So again, to scale 1:10, if you make that 5 millimeters each stud 5 millimeters. Okay, and you're going to have in between the studs, okay, every stud, it's 400 millimeters center to center on the studs. 400 millimeters center to center on the studs. Okay, and you've got 1, 2, 3, 4. Now the fourth stud is also a jamb. So this here is going to be jamb, and it is going to be, instead of 95 by 45, it's going to be 95 by 70. So it's going to be 7 millimeters here. Okay. Now I've given it a distance of, for universal design here. Basically I've given it a distance here. If you want to put a distance here on the inside between the jambs, I've given it a distance of 950 millimeters. 950 millimeters between these jambs here. Okay. Now, obviously, universal design is to allow obviously a wheelchair access. So there's particular doors and door widths that are required for that. Okay, so the jamb on this side here then is 7 millimeters in thickness here. Okay, and then it is, again, you're back to your 400 centers. So your studs over this side here, you've only got 2 studs in place, and 400 millimeter center to center. Then another 3 millimeter gap, 30 millimeter gap between the internal wall here and the last stud here. And what we're going to have is folding wedges in strategic positions here as well. Okay. Now we've also got in between the cavity wall here, so between the inner leaf and the outer leaf, just wall ties put in at the different locations there. Okay, I've dropped them down 400 millimeters. I've kept one in line here with the top of the or the bottom of the joist here. Okay, so a wall tie here and then 400 millimeter down for each one, just to indicate the wall ties. The joist then, I've got the first joist on the suspended timber floor here, upper floor. So I've got the first joist, okay, sitting on top of the first stud by way of location. Okay, and in between, the spacing in between each joist, is 400 millimeters in between each joist. Okay, now there's a joint that is going to, a joint detail that is between the jamb and the head here. Okay, and I've drawn this as an isometric here. So starting with the crow's foot, so 90 degrees, 30 degrees, and 30-degree return. So basically that gives you how to shape the isometric. So I'm going to draw that in as well as a detail for this joint that's going to be here. Now I'm going to just go ahead and ink this in so that the details become more prevalent. So you should be able to start constructing the scale drawing, and as I ink it in, I'll go through different details with you. We have, if I just push that up a little bit, we have the cavity wall. Okay, so we've got the outer leaf, inner leaf, and I'll put in just the indications of obviously the zigzag lines and so forth, the symbols for the various walls, the various parts of construction and scale drawing. I'll put them in shortly. So this is your exterior wall, this is the concrete floor, and this is the hard core underneath, and you have obviously then your DPC and your DPM linked into the DPC here going underneath the concrete. Obviously you would have that insulation board as well as part of this floor construction, but what I'm focused on is the particular stud partition as part of first fixing. So we haven't filled in those details yet. This is purely just to give the obviously the construction within which the stud partition is going to be framed. Okay, so to continue on then. Okay, so they are all the first floor joists in place to a suspended timber floor. Now what I'm going to draw now is in place is the partition underneath. Okay, so the noggins are at the mid height here of the stud. So they alternate. So one, the center line, if I put in here first, get the noggins in place. So that is your stud partition in place. Okay, what I'm going to draw now in here, this is obviously a detail here with regards to the jamb, the construction of the head going into the jamb on each side of the head. Now I've got an isometric sketched out here, and I'm going to just draw in the details of the isometric here and ink. Now I've drawn this isometric scale 1:5. And the wedge at the back. So this would be referred to as similar to what would be like a Tusk tenon joint. So you've just basically got a wedge at the back that sits into this recess here, this mortise, okay, on the tenon. So when the tenon sits through into the mortise here, okay, and you've got this part here of the shoulder sitting into the jamb, but then the tenon goes through and it's locked in place with the wedge. Now, Tusk tenon joint would be the traditional joint that would be used for attaching the trimmer joist into the trimmed joists. So or rather the trimmer joist into the main joist. So what holds up the staircase at the top of a staircase, it's that particular trimmer joist is jointed into the joists on each side of it using what's referred to as a Tusk tenon joint. So this is quite similar. Okay, I'm just going to put in the end grain details here. Okay, and just detail the end grain there. Yeah, so that's the scale drawing of the stud partition inside, set inside. So you've got the exterior cavity wall here, you've got your concrete floor on the bottom, and you've got an internal wall here on this side here. Now I didn't put in the zigzags on this, so similar zigzags to this inner leaf here on this side here. Okay, now on the top part here, okay, you've got the joist, the flooring joists. Okay, and so the flooring joists are 9" by 2", okay, or 225 by 45 millimeter. Okay, so that indicates solid supports in between the joists there. Now on this side here, I'm just going to put in what's referred to as herringbone strutting. So this, I'm going to put the herringbone strutting on this side here. This is the solid strutting here in between the joists. I'm just going to indicate an alternative herringbone strutting in between the joists over this side, just to show you the two different ways of doing it. Now, the solid strutting would be 50 millimeters, 2 inches thick. Okay, obviously the same material as your joisting. So this is 225 by 45, so these would be 45 millimeters in thickness. The herringbone strutting will be 50 millimeter, obviously depth, but 38 millimeters in thickness. Okay, now so just to indicate again the sizes there. So I'm going to come up very simply 6 millimeters here on this side here, 60 and 60 here. All right, so now that point is going to go to here, and this point is going to go to here. Okay, now I've got one in place here. Now what I'm simply going to do is I'm going to use my T-square, if I can find it, whatever I did with it. Ah, got it. So I'm going to use my T-square to take these positions here. So this position here, 1, and this point here, let's bring that up here. Okay, so the strutting will go from the 6 millimeter point to the top point there, and the other one. So this point here to here, this point here to here. Now, and then the other side. Wrong line there, that point there, to that point there. So I'm going to ink those in. That's your herringbone strutting in between the joists, and this is your solid strutting in between the joists. Now you can also get a metal variation of the herringbone strutting, so metal supports that do the same thing as the herringbone strutting as well. So to recap then, we have your cavity wall here, the exterior cavity wall. We have the concrete floor at the top here. We have the first floor, suspended timber floor here. We have the joists in place. We have two different forms of strutting. We've got solid strutting and we have herringbone strutting. And then we have the stud partition in place. So 400 millimeter center to center studs. There's a gap here of 30 millimeters. Now there's going to be folding wedges here and here. I haven't indicated them yet. But I have a joint detail here. So I've got these particular studs here are 95 millimeters in the depth, and then 45 millimeters in thickness here, except for the jambs. The jambs are 70 millimeters in thickness rather than 45. And the head here is also 70 millimeters in thickness. Okay, and then you have your interior wall here, which the stud partition is coming up against. Now I'm going to just indicate where the folding wedges are. And the folding wedges are located here. size over this side. Just a bit of end grain. Folding wedges in place. Okay, and they basically lock the partition into position. Obviously then the fixings can be put through the folding wedges, okay, into the walls, the interior wall and the cavity wall. Now, so I'm just going to finish off this here with regards to the defining the interior wall here, putting the same zigzag here on this side here. Okay, interior wall here is vertical, and the stud situated between the cavity exterior wall and the interior wall here, and on top of your concrete floor and underneath your timber suspended first floor. And you have obviously your different details with regards to your studs, 400mm center to center, the different sizes of the studs. So these studs here are 95 by 45mm, and over on this side the same, except for where the door is. So you've got the jambs here and the head, and the two jambs and the head are 95mm by 70mm, 70mm here. So it's 45 for the other studs, 70mm for the jamb and the head. And the joint detail here, particular joint detail for the head going into the jamb here, and the tenon then locking the head into position. Okay, you also have solid strutting here in between the joists, and you have herringbone strutting in between the joists here. Now again, basically fixing in between here, obviously. So the herringbone strutting there. And I'm just going to shade in then just the end grain here for this particular joint. Okay, so first fixing to scale 1:10, that is a stud partition, okay, with your first floor timber suspended floor. You've got solid strutting, herringbone strutting, and you've got your detail with regards to the jamb and the head and the joint detail here. Folding wedges on the side, locking your stud into position, and your fixings then would go through obviously the folding wedges and basically lock them in position also. Okay, I hope you found that video useful. Thank you very much.